module, and me and my buddy Zeke, who's not here right now, but we're gonna be introducing the concepts of kinetic and potential energy to y'all. And basically, potential is energy stored in an object, while kinetic is energy flowing through an object. So let's say an object is on top of a hill, it will have potential energy. Meanwhile, when it falls down, it will gain kinetic energy and lose potential energy.
Today, I'm going to take you on a journey through the fascinating world of physics, specifically focusing on the two fundamental concepts that drive much of the motion and energy around us: kinetic and potential energy. Understanding these concepts not only deepens our appreciation for the physical world, but also enlightens us on the principles and underpin various technological advancements and natural phenomena. Let's start with potential energy. Imagine standing at the edge of a cliff, holding a rock in your hand. That rock, held high above the ground, is brimming with potential energy due to its position. Potential energy is the stored energy an object possesses because of its position or state. It's like the energy waiting to be unleashed. There are various types of potential energy, but today we'll focus on gravitational potential energy, which is influenced by height and mass, and elastic potential energy found in objects that can be stretched or compressed. Now picture yourself letting go of the rock. As it falls, the potential energy it had while in your hand begins to transform into kinetic energy. Kinetic energy is the energy of motion. The faster the rock moves, the more kinetic energy it gains. This transformation continues onto the moment before the rocks hit the ground, at which point all the potential energy it had has been converted into kinetic energy. This seamless transition illustrates one of the most fundamental principles in physics, the conservation of energy, which tells us that energy cannot be created or destroyed, only transformed from one form to another. The relationship between potential and kinetic energy is beautifully demonstrated in many everyday phenomena and activities. Take for example a roller coaster. At the top of the first hill, the roller coaster car is filled with potential energy. As it races down, the energy is converted into kinetic energy. That energy is converted into kinetic energy, propelling it up the hill, where the process begins anew. This is interplay is a dance of energy transformation, a showcasing of conversion between potential and kinetic energy. Now let's explore how these concepts apply to the world around us, particularly in renewable energy technologies. Hydroelectric power plants, for instance, realize the potential energy of stored water in the reservoir. When the water is released, its potential energy is converted into kinetic energy as it moves towards and spins a turbine, which then generates electricity. Similarly, the wind turbines harness the kinetic energy of the wind to produce electricity. These applications are not only practical demonstrations of potential and kinetic energy at work, but also highlight the importance of understanding this concept for sustainable development. In the realm of sports, the principles of kinetic and potential energy play pivotal roles as well. Consider a diver poised on the edge of a diving board. The diver has gravitational potential energy due to the height above the water. As they dive, this potential energy is converted into kinetic energy, culminating in a splash as they enter the water. Understanding the interplay between potential and kinetic energy can help athletes optimize their performance, whether it's in maximizing the height of a jump or the speed of a sprint. In conclusion, the concepts of kinetic and potential energy are not just abstract principles confined to the realm of just physics textbooks. They are vividly alive in the world around us, driving the motion we see in nature, the sports we play, and even the renewable energy technologies that we are increasingly relying on. By understanding these fundamental concepts, we gain insight into the very workings of the universe. I can apply this knowledge to innovate, conserve, and inspire. Thank you. Bicycles convert about 90% of pedal power into kinetic energy, but cars are less efficient, converting only about 25% in gasoline into motion, losing the rest of the E. Fucked up.
You could have kept going.
Fucked up.
Keep going. I have CapCut. I can cut it.
Losing the rest as heat due to engine inefficiencies.
All right, go.
As I'm moving, the kinetic energy gets bigger. As I come to a break, the potential energy comes to a max. Braking is very important in bikes. As I move my legs, the energy is being transferred from my legs to the bike.
Another example we can show for kinetic and potential energy is by using this ball and these stairs. At the top of the stairs, the ball has the most potential energy, but as I drop it, it gains kinetic energy. And once it hits the bottom of the floor, it regains that potential energy. They just switch back and forth, basically. The total energy will never change. Another example could be this water bottle. As I throw it up, its kinetic energy will rise, and as it falls down, it will go down. As I previously stated, kinetic and potential energy go hand on hand with each other. If potential goes up, kinetic goes down, and vice versa. It all adds up to the same total energy in the end. So ready? 3, 2, 1.
As I begin to run, my kinetic energy increases. As I come to a stop, my potential energy increases.
Said before, cars do not produce as much kinetic energy as bikes, but that does not mean that they don't produce any at all.
Right.
So as I move my car here, kinetic energy is rising, but it quickly comes to a stop as I brake.
The rock is at its max potential energy at this height, and as we drop it, it reaches max kinetic energy.
A great example of kinetic and potential energy is using this kettlebell and making a circle with it. As I bring it up, its kinetic energy goes its kinetic energy goes down and potential goes up. Once it's up here, its potential energy is at the max, and once I drop it again, at this point potential and kinetic are equal, since as kinetic goes down, potential goes up. And right here, this would be the max kinetic energy. That's good. So that was our video on kinetic and potential energy. We really hope y'all enjoyed. If y'all have any more questions on physics, I'm an expert at it. You can put them in the comments. And yeah, make sure to like, comment, and subscribe, and we'll see y'all in the next project.